Okay, so mole to mass conversion. We know that there is a link from mole to mass. In order to be able to convert successfully mole to mass, we know that the crucial conversion factor that we need to get is the molar mass. So the very first step to calculate or to do this type of conversion is to be able to determine the molar mass of the given compound. And molar masses are taken from the atomic mass of every element found in the periodic table. When we get to multiply the quantity and then we sum up everything to get the molar mass of that substance given, so that we can use that molar mass for our second step, in which we will be multiplying the given with that molar mass that we get from step 1, so that in the final answer we will be able to get the mass which is in the grams unit. And so to illustrate that, we have one problem here that we also discussed beforehand, and this problem shows us those two steps. So the first problem was this conversion from 1.06 moles of Ca3PO42 to its mass in grams. So the question is, how many grams are there in this 1.06 moles of this substance that we have here? So the very first step is we calculate the molar mass of that substance that we are given. So molar mass is calculated this way. So each element is listed. After that, we get the quantity of every element from the subscript of those elements in the given chemical formula. And then after that, we looked at the periodic table for the individual atomic mass of these elements. And after we copied all the atomic mass, we multiply them, each one, to get individual products here. And once we get the products from the multiplication, then that's the time we're going to total and sum up everything to get the accurate value for your for the molar mass. So the 310.174 is our molar mass of Ca3PO42. That's why the unit is grams per mole. Always, the unit for molar mass is grams per mole. And once we're done with the molar mass, we proceed to step 2. And step 2 says that we need to multiply the given with the molar mass taken from step 1. So always you write the given first, which is this. So we wrote it here, 1.06 moles. And then we multiply it to the molar mass that is enclosed in parentheses. So we just copied this value, placed it here. The 310.174 grams will be on top. And the per is written as this horizontal line, and the mole is placed below. The mole is always a 1 mole because the molar mass is defined as the mass of 1 mole of any substance. So it is very safe to place a 1 mole there to complete our conversion solution. And through this way, the mole below and that mole in the given will cancel out. We don't need the mole unit. We just need the gram unit, which is the one on top. So by canceling that out, we're confident that our moles are out of the picture already. And now after canceling it, you use your calculator to be able to multiply 1.06 and then times 310.174 grams. And we should be able to get the answer 328.78. And the unit for that is grams. I just made the word grams here to make it clear that G means grams of our substance Ca3PO42. And that's one example to illustrate that information. So let's solve another problem here, our third problem, which is solve for the mass of 4.67 moles of NaClO4. Take note, this is a Cl, not a Ci. This is a small letter L. So Cl is one element here. So let's proceed to the very first step, step 1, which is calculating for the molar mass of NaClO4. So we get to list down all the elements present for our chemical formula. So that's Na, and we have Cl, and then we have oxygen. And then beside it, we're going to look at the quantity from the subscript. So Na and Cl, they do not have a subscript, so that's understood to have one only. And then for oxygen, there are 4 because we see a subscript of 4 there. After that, we're going to put multiply, multiply, multiply to remind us that we need to look at the periodic table, look for the atomic masses of these elements that we listed here. So let's start with Na. Na is 22.99, so we're going to write it here, 22.99. Cl is here, which is 35.45. And then lastly, for oxygen, it's 15.999, or sometimes it's going to be rounded up to 16. That is fine. I will just follow my 15.999 so we don't get confused with our source. After that, we are going to multiply our quantity. So the 1 times 22.99 will be obviously 22.99. Same thing with chlorine, that's just times 1, so that's 35.45. And then for oxygen, we have 4 times 15.999, and that's equal to 63.996. After that, we're going to sum up everything. So 63.996 is already in my calculator. I'll add 35.45. Then I'll add the 22.99. And that's equal. You should be able to get 122.436, around that value, for the molar mass of NaClO4. And we should not forget to write the unit grams per mole for our molar mass value. So let us box the molar mass value here, and that will indicate our step 1 that is already done. Once we are good with step 1, we go to step 2, and step 2 is now we multiply the given with the molar mass. So I'm just going to abbreviate that as mm, molar mass from step 1. Okay, so now we're going to write down our given first all the time, and our given is in the problem itself, so 4.67 moles. So let's write that down. That's 4.67 moles. And then we multiply that with the molar mass. So we're going to enclose our molar mass in a parenthesis so we can write that properly. The 122 will be on top, 122.436 grams. And then, of course, the per is here, and then the one beneath it will be the 1 mole. The per mole. The mole is 1 mole all the time. Then we close the parenthesis, and then we cancel our mole unit to emphasize that we don't need it anymore. And now we're ready to input this in our calculator. So we're going to multiply 4.67 times 122.436 equals, and so we get a lot of numbers here. We just limit up to the second decimal place, which is after the decimal point. We have 2 numbers after that, so that's 77. But the third decimal place number is 6. It's above 5. So the second 7 here would have to be rounded up. So our final answer will become 571.78. So the 7 will become an 8. And of course, the final unit will be the G. And I will just write the word grams here to emphasize that. G or grams will do. And then of our substance is NaClO4. So let's mention that as well in our final answer. And so the final answer is 571.78 grams of NaClO4. And that's how we solve the mole to mass conversion.